Hey guys, what's going on? Nick here from the Investigator YouTube channel. In today's video, you're going to learn about the concept time value of money. If you're studying finance, accounting, or maybe getting ready to start investing, you're definitely going to come across time value of money problems in one form or another. In this video, I'm going to give you an easy definition, then I'm going to run through a few examples, and by the end, I'm going to make sure you're ready to go through advanced time value of money calculations. Now, I just want to let you know that this is the first video of a time value of money series that I've put together for you guys. I've got a link to the playlist down below in the description, and I've also linked it up above in the card. Now let's get into it. So what's the definition of time value of money? Basically, $1 today is worth more than that same dollar tomorrow. This is because we can put our money to work and earn interest on it. We're able to place our money into an investment vehicle such as a bank, and together with time, we can grow it to a much larger amount. So basically, we say that we value money greater the earlier it is received, as it really gives us a larger time horizon to grow our funds. So what's important to consider when dealing with time value of money? Firstly, we have to look at the amount of money. What amount of money are we set to receive or pay? And then also, at what point in time are we set to receive or pay that money? Now, always remember that money and time are related. $10 today will have the same value as $20 at some point in the future. Just keep in mind that different amounts of money at different points in time can have an equivalence in value to you. Alright, now let's get ready to start the examples. And I just want to let you know, we're going to be using simple rounded numbers. They might not be entirely realistic, but it's going to be much easier for you to follow. Let's jump into them. Now, for this first example, let's say I was to offer you a $100 note today, or that same $100 note, but 1 year into the future. Which offer would you take? Now, obviously, you're going to take the $100 today. Why would you wait? But why is this so? Doesn't $100 today have the same value as a $100 note 1 year into the future? This isn't the case. While the physical amount might remain the same, its value has definitely changed. Let's say you have a savings account available to you with your local bank, which pays you 10% on your money per year. You take the $100 today, which we will call the present value. We invest it in the bank, and we want to grow that for 1 year at a rate of 10%. Firstly, what we want to do is turn our 10% interest rate into a number that we can work with. To do this, just grab a calculator and punch in 10 divided by 100. And if you compute that, what you'll get is 0.1 as a decimal. But because we're going to grow our funds into the future, you simply want to add a 1 to this. So just plus a 1 onto this. So we could say that's another equation. And what that's going to give you, obviously, equals 1.1. Now that we've got this number to work with, what we can do now is work out our future value 1 year into the future. So our future value. To do this, we're simply going to multiply our $100. So multiply 100 by 1.1. And once you punch that through the calculator, you'll see that your $100 is going to grow to $110, which we can call the future value. Given the current scenario, you could say that your $100 has a future value of $110 in 1 year from now. You could also say that your $100 is the present value of $110 in 1 year from now, given the current rate of interest available to you. Now, it's important to note that if you took the second offer, the $10 you would have gained by taking the money today and investing it at 10% is known as your opportunity cost. Opportunity cost is the value of different opportunities that you have forfeited by taking a particular or different course of action. Alright, now what we're going to do is go through one more time value of money exercise just like this one here, just to really wrap your head around things. Then once we're done with that, I'm going to introduce you to the time value of money formulas. And together, we're going to solve future value and present value equations using formulas which are commonly found in corporate finance and valuation. Alright, for this next example, we're going to assume that you still have access to your super high 10% interest savings account at your local bank. Now, you've bumped into me on the street, I'm feeling super generous and I want to give you some money. But I present you with 3 options. Now, option 1, you can take $10,000 today. Option 2 is to take $10,800 in 1 year from now. Or option 3 is to take $11,600 in 2 years from now. Now, to be clear, all these options are guaranteed. You don't have to worry about me changing my mind or running away. Whichever option you decide to take, you're guaranteed to receive the money. So to compare which option is better for you, we need to do a few calculations. Let's assume that you've decided to take option 1 and you take your $10,000 and stick this in the bank, and like the previous example, this will become your present value. Now, what we want to do is we want to grow our present value, our $10,000, into the future to get a future value of years 1 and 2 into the future to get an equal comparison on the offers. Like we did in the previous example, you want to start off by multiplying your present value, which is now $10,000, by 1.1 to grow it into the future. So multiply by 1.1 our 10,000, which will give us a future value 1 year into the future of $11,000. So as you can see, compared with the offer of $10,800, by taking option 1, you're $200 better off than taking option 2. Now that we've got our future value in year 1 of $11,000, so future value year 1, what we want to do is compare this with option 3. So to get an equal comparison, we need to grow it again into the future at 10% interest. So we're going to just simply multiply now our $11,000 by 1.1, which will give us a future value in year 2 of $12,100. Now with these calculations completed, we've demonstrated that not only is option 1 greater than option 2 in value, you're also going to be $500 better off than the $11,600 offered to you in option 3. Now guys, I know it's not realistic to be getting 10% interest on your savings account in your local bank. I live in Australia and currently I'm getting 1.8% on my savings account. Now with everything going on in 2020 and the economy being where it is, I don't really see this increasing anytime soon. I'd really be interested to know what kind of rates of return everyone else is getting around the world on their savings account. So comment down below if you don't mind sharing with your interest rate and what country you're from. When we went through the previous examples, we individually calculated for each time period. I did this so you could visually see what was going on in every step. Now we're looking to solve future and present value calculations. You're able to do so using the following formulas. So if you're looking to solve for future value, the formula is simply present value multiplied by 1 plus r to the power of n, and that's in parentheses. And if you're looking to solve for present value, the formula is future value now divided by 1 plus r to the power of n, and again in parentheses. Now r is the interest rate, and you always want to remember to transfer your interest rate into decimal form, just like we did in the previous examples. And n is the number of compounding periods. And in the previous examples, we're working with yearly compounding periods. But what I'm going to do, we're going to do 2 examples, one for each formula, so you can really understand how to use them in practice. So let's get into that. Okay, for the first example, we're going to look to calculate for future value. So the question is, what is the future value of $10,000 invested for 2 years at 10%? So we're going to start off by using the formula here, which is future value is equal to present value multiplied by 1 plus r to the power of n. Now we just want to fill this in. So our present value is $10,000, and we're going to multiply this by 1 plus 0.1, and the compounding periods are 2. Now once you commute that through your calculator, you're going to get a future value of $12,100. Now this future value of $12,100 is obviously going to be familiar from the previous example, and that's because it's pretty much the exact same calculation we're doing, just this time instead of calculating for each time period 1 year at a time, we've done the whole lot in one calculation by using the formula. Alright guys, what we're going to do now is we're going to solve for present value using the formula, and the question that I've got for you is what present value invested for 2 years at 10% will grow to a future value of $12,100. Now to do this, we're going to be using the following formula, which is present value is equal to future value divided by 1 plus r to the power of n and in parentheses. So simply we're just going to plug in the gaps. So present value equals future value, which is our $12,100. So 12,100. And we're going to divide that by bracket 1 plus R, which is 10%. And as a decimal, again, 0.1. Bracket N is our 2 compounding periods. So we're just going to plug a 2 up here. And if you compute this through your calculator, you should come to your present value of 10,000. And it's as simple as that. I hope that you all now understand the time value of money concept, and I really suggest watching the next video in my series where we start to have a look at more advanced calculations, starting with future value of single cash flows. Now guys, if you've enjoyed this video and you've got value, please be kind enough to smash that like button. It really helps support my channel and lets me know if you're getting value from my content. That's all I've got for you today, guys. See you in the next video. See you later.